Our last shuffle today is the Australian Down Under. Now, as we'll see, this shuffle is highly chaotic. It is scrambling the cards in a way that none of the other shuffles do, actually. But nonetheless, it will actually be a Bessey shuffle. Now, this one won't preserve a Bessey sequence, but it will invert it, which for our purposes is just fine. Okay, so to show you how we got the cycle notation for the Australian Down Under, we begin with an ordered packet, 1 through 8. We perform the shuffle, and then we look at the new ordering. So the Down Under, how this works is you put the top card down, next one goes under, down, under, down, under, down, under, down, under, down, under, down, last one goes on top. So what is the new ordering of the cards? Well, let's take a look. So it looks like it's 8, 4, 6, 2, 7, 5, 3, 1. Okay? And that's what I've indicated down here using Cauchy's two-line notation. We see that we get the following representation. Of course, the top row is always 1 through 8 for what we're doing. And then the bottom row is 8, 4, 6, 2, 7, 5, 3, 1. Now, two-line notation can be converted to cycle notation as follows. We look at what happens with 1. 1 gets sent to 8, and then 8 gets sent to 1, so it wraps back around. So we get a transposition, or what's also called a two-cycle. What happens with 2? 2 gets sent to 4, and then 4 gets sent to 2. We get a second transposition, or two-cycle. What happens with 3? 3 gets sent to 6, 6 gets sent to 5, 5 gets sent to 7, and then 7 gets sent back to 3, so it wraps around. So we get a 4-cycle. If we color code our numerals, we get the following. Black 1 being sent to red 8, and red 8 goes to black 1, it wraps around. Red 2 goes to black 4, which wraps around to red 2 again. Red 3 goes to black 6, which goes to red 5, which goes to black 7, which goes back to red 3. So we can see here that each value gets sent to a value of the opposite color. And because of that, inversion has indeed occurred. So once again, inversion occurs if the cards originally in positions 1, 4, 6, 7 get moved to positions 2, 3, 5, 8 in some assignment, and vice versa. Cards that began in 2, 3, 5, 8 positions get moved to positions 1, 4, 6, 7. And in the case of the Australian Down Under, inversion does indeed occur. So using our Bessey sequence 1, 0, 0, 1, 0, 1, 1, 0, why don't we go ahead and quickly demonstrate that inversion does occur. So the Down Under, it's down, and then the next card goes under, down, under, down, under, down, under, down, under, down, under, down. Last one goes on top. So instead of 1, 0, 0, 1, 0, 1, 1, 0, we should get the inversion of that, which is 0, 1, 1, 0, 1, 0, 0, 1. Okay, so the cards labeled 1 here originally started in the positions currently occupied by the zeros, and vice versa. So it truly is the case that the zeros and ones switch places in some way. That's called an inversion. And to quickly step through the Bessey shuffle diagram, we can come over here. We see that we have 2 transpositions. So what that means then is we should expect 2 double arrowed lines, one between 1 and 8, which we have right here, and one between 2 and 4, which we have right here. Now the other values are being moved around in kind of a messy fashion here. So 3, so if we go down to 3, which is right here, it gets sent to 6 straight across. So there's an arrow from 3 to 6. 6 goes to 5, which is down here, which you can't see at the moment. And then 5 goes up to 7. And finally, 7 goes back to 3, which completes that cycle. So here we would say that values 1 and 8 are in the same orbit, 2 and 4 are in the same orbit, and 3, 5, 7, 3, 6, 5, 7 are in the same orbit. And here I've indicated that inversion has in fact occurred. And then note down here, I have no indication as to any other shuffle that is either the inverse of the Australian Down Under or identical to it, that I will be featuring in this series devoted to Bessey shuffle diagrams. Okay, so let's finally show an application of all of this here.